Fifth grade lesson 7.10 is problem solving, finding an unknown length and dealing with fractions and using your calculations. Eventually you learn all these formulas for solving these, so you don't have to guess. But if you don't have those yet, guessing is a mechanism for getting to some of those answers. So let's take a quick look at this. Our essential question is, how can you use the strategy to guess and then check and then revise or adjust to solve problems with fractions? Let's have a look at this. Sarah wants to design a rectangular garden with a section for flowers that attracts butterflies. Who wants to attract butterflies? I don't like butterflies. Okay, anyways, I'm drawing a rectangle because they said rectangle. She wants the area of this section to be 3/4 of a yard. So if we multiply the length times the width, we should get 3/4 of a yard. So length times width will be 3/4 of a yard. If she wants the width to be 1/3 of the length, what will the dimensions of the butterfly section be? So we want the length to be the length, and we want the width to be 1/3 of the length. So 1/3 times that. So we're going to have to do some calculations. We know what we're going to do is have to multiply a length times width, but it looks a little funky at first. You'll see. So I need to find what the length, and then once I find the length, then I can multiply that by 1/3 to find the width, basically the dimensions of the garden. What information do I need to use? The part of the garden for butterflies has an area of 3/4 square yards, and the width is 1/3 the size of the length, so it's smaller than. So if I cut that length into 3 equal pieces, one of those pieces is what the width will be. I will use the information, I will guess the sides of the butterfly area. I'm going to make some guesses, and then I will check my guess and then adjust it or revise it. So guess, check, and revise until I learn a formula later for solving that. I can try different lengths and calculate the width by finding 1/3 of the length for each length and width. I find the area and then compare it. If the product is less than or greater than 3/4 square yard, I will revise it. They did a lot of this for us, and I'm going to explain the way through because I feel like if you were to try and understand what they were doing without an explanation, it might be confusing. So their first guess, they said, is, I think maybe the length is 3/4 of a yard. Okay, if that's our guess, let's test it out. We know that this is going to be 1/3 times that. So I would say, let L equal 3/4. Let's let L equal 3/4 and see what happens. And I know that I need to take the length, 3/4, over here, and multiply it times the width, but I don't know the width yet. So if we're guessing that it's 3/4, then let's find out what the width will be. And I'll just put 3/4 here. If we're making the guess that it's 3/4, we need to find what the width will be. It's 1/3 times the length of 3/4. So we will do 1/3 times 3/4, and that's what they're doing right here. And they, of course, get the answer 1/4. I am just going to do it real quick just so you can refresh your memory on the multiplication. They are both fractions already. Cross-reduce if you can. I sure can. 3 goes into 3 once, 3 goes into 3 once. Multiply straight across. 1 times 1 is 1. 1 times 4 is 4, and we get 1/4. So now I'm going to fix this over here to be 1/4. So I have the length 3/4 and the width 1/4 now. Will that in fact give me 3/4? Let's find out. 3 times 1 is 3, and 4 times 4 is 16. No, that is not 3/4, it's 3/16, and that's smaller. We still have 3 equal pieces, right? But this one was a pizza cut into 4 equal slices, so those are pretty good sized slices. This one is the same size pizza cut into 16 slices. You have to share it with 16 people, and those are tiny, tiny slices. So 3 tiny, tiny slices and 3 good sized slices. So this is way too small. I need a number bigger than 3/4. So here's my revise. Okay, so no problem, no problem, no problem. It is not 3/4, it's bigger. So then they said, well, let me try 2 and 1/4. And then, of course, 2 and 1/4, you multiply 2 times 4 is 8, plus 1 is 9 to get 9/4 because we need to change it all to fractions. So we're saying, what if it's 9/4? Then I'm going to do 1/3 times 9/4, 1/3 times 9/4 to find out what the width will be. And if I can cross reduce, that'd be nice. And I can. 3 goes into 3 once, and 3 goes into 9 3 times. 1 times 3 is 3. And 1 times 4 is 4. So this ends up being 3/4 right here. So I now have the length of 9/4 and the width of 3/4. And we'll check that in the moment, but let's go ahead and fill this in. We did the 1/3 times 9/4, and we got 3/4. That gave us the width here. So now we're going to do the length times the width to find out the area, 9/4 times 3/4, to see if we get 3/4. Cross reduce, not there. Cross reduce, not there. 9 times 3 is 27. And 4 times 4 is 16. That's an improper fraction. I'll just do bottom into top. Divide the bottom number into the top number. And the remainder is the numerator. So it's a number, improper fraction when the number is bigger up here means we know it's more than 1. Just how much more than 1? 16 goes into 27 just the one time. With 11 out of 16 left over. Well, this answer is certainly not 3/4. This is more than 1 even. 3/4 is less than 1, right? If I'm only getting 3/4 of a candy bar, I'm not getting a whole candy bar, and somebody else over here is getting one whole candy bar and some more. 9/4 or 2 and 1/4 is too big. So we need to be bigger than 3/4, but less than 2 and 1/4. Let's go for a, I don't know, 1.5 maybe? Let's try 1.5. Let's see what happens with that. And we know we've got to convert this over to make it workable. 1 times 2 is 2, plus 1 is 3. So 3/2. So let's say, what if our length is 3/2? What would that make my width then? Because it's 1/3 times 3/2. So I'm going to make my guess that 1.5 or 3/2, same thing, right? Now I will do 1/3 times 3/2 to get the width. I can cross reduce. I'm going to do it over here where I can see it better. 3 goes into 3 once, 3 goes into 3 once. Okay. 1 times 1 is 1. And 1 times 2 is 2. I end up with 1/2. That is for my length, my width. Sorry, 1/2 is my width. And my length is 3/2. What a mess over here. I apologize. I need to do the 1/2 times the 3/2. Let me explain that so you know where I'm getting these numbers from. Remember, length times width is 3/4. 3/2 was my guess. I did 1/3 times 3/2 and got 1/2. So that's my width. So that's why I'm doing 1/2 the width times 3/2 the length, or length times width. Sorry that got so messy. Now let's calculate it. 1 times 3 is 3. And 2 times 2 is, 2 times 2 is 4. And that's what I was after. 3/4. Ding, ding, ding. Winna, winna. Chicken dinner. It's 1.5. That was so lucky. I thought we were going to have to multiply that more times. Phew. All right, let's look at another problem. Because we want to do this again. Try another problem. Marcus is building a rectangular box. Draw a rectangle for his kitten to sleep in. He wants the area of the bottom of the box to be 360 square inches and the length of one side to be 1 3/5 the length of the other side. Oh my goodness. Okay, what should the dimensions of the bottom of the bed be? So let's break this down. We've already started with the picture. That's helpful. We want the area to be 360. So let's write 360 in there. And then also over here, I know the area equals length times width. My area needs to be 360. What else do we know? The length of one side needs to be 1 3/5 the length of the other side. So it's going to be a bigger. It's 1 times and then some times one side. So the smaller one is the width over here. So the width is the unknown part that I don't know. I also don't know my length either because it's reliant on me knowing my width. But whatever the width is, then I will multiply it times 1 3/5 to find my length. So what do I need to find? I need to find my dimensions. I'm just going to put dimensions there of the box. I need to find the length and the width. Those are the dimensions, the measurement of the length and the width. What information do I need to use? I need to use the area that I know, 360, and then I use the 1 3/5 times the width to find the length once I guess what the width is. How will I use that information? I'm going to guess, I'm going to check, and I'm going to revise. Okay, a little bit of math to do. No problem. We are perfectly capable. We are smart peoples. Let's see. This is pretty big number. And in my head, I'm trying to think of ways that I can build 360. Well, I know if I took the 0 off, 6 times 6 is 36. So if I had a 0 on there, then one of those is going to have a 0 on there. Like 6 times 60 is 360. Now, those are far apart, not 1 3/5 more. That's a lot more. So I'm just going to make some adjustments to that. Maybe I'll go with I know that 9 times 4 can build 36 as well. So if I said 9 times 40, that would give me 360. I know I have some fractional things going on. I'm just trying to get myself close so that I can make some reasonable adjustments. So I think I'm going to go with saying, so if I did 9 times 40, 9 would be the smaller side, the width. So I'm going to say, let's try this problem with letting the length, or I'm sorry, not the length, we're looking for width, with width being 9. And let's experiment, let's check. So we know that area equals length times width. And in this case, I don't know my length, but it's 1 3/5 times W. Well, I'm going to convert this right now. 1 times 5 is 5, 6, 7, 8. That's 8/5, so that it's workable. I know the length is 8/5 amount times whatever W is, and we're guessing that W is 9. And then we would multiply that times the width, which is in fact 9. So we have to do what's in parentheses first. I cannot cross reduce, so I'm going to get 72/5 times 9 over 1. That's a bad choice. Now I have these gigantic numbers. 72 times 9. I have to do it over here. That's 18. 63, 64, 648. And 5 times 1 is 5. Now I have to convert that back out again. 5 times 1 is 5. Gets me close. 5 times 2 gives me 10. And 5 times 9 gives me 45. With 3 out of 5 left over. Okay, I was looking for 360 and I got 129 3/5. Way too small. So I got to go bigger. Maybe I'll try 15. Okay, so scratch this out. No. Maybe I'll try 15. That's my next guess. It's higher than the other one. And then we're going to do 15 for my width. So area equals length times width. So length we know is 8/5 times the W, which we're saying is 15. 8/5 times 15. And then we will multiply that times 15. Again, because that's the width now. Oh, I can cross reduce. Thank goodness. 1, 3. 5 goes into 5 once, and 5 goes into 15 3 times. 8 times 3 is 24. I'm going to multiply that times 15. Oh, please be 360. Let's see. 5 times 4 is 20. 5 times 2 is 10, 11, 12. 1 times 4 is 4. 1 times 2 is 2. It's 360, you guys. 360. Winner, winner. Chicken dinner. That was what I wanted. Oh, lucky guess. Okay. I was hoping I didn't have to calculate it again. So we started at 9, it was too low. We lucky got up to 15, and that just worked out just right. So the dimensions of the bottom of the kitten's bed will be, we had this 24 by 15. So we have a 15 width and a 24 length. Woo! And this bottom part says, what if the longer side was still 1 3/5 the length of the shorter side, and the shorter side was 20 inches long? What would the area of the bottom of the bed be? I don't mind this question because they gave me that unknown. So I have area equals length times width. And I know the shorter side, the width is 20 now. They told me so. Thank you very much. And then we're doing 1 3/5, which we converted to 8/5 times that 20. So 8/5 times 20. Cross reduce, yes I can. 5 goes into 5 once, and 5 goes into 24 times. 8 times 4 is 32. And 32 times 20 is going to give me the area, which is what they were asking me for. And so 32 times 20, 0, 0. 2 times 2 is 4, 2 times 3 is 6, 640 square yards. Okay, let's do this share and show. Breathe, everybody. We got this. We can do this. We can do this. If we do this together, we got this. When Pascal built a doghouse, he knew he wanted the floor of the house to have an area of 24 square feet. We want the area to be 24 square feet. He also wanted the width to be 2/3 of the length. What are the dimensions of the doghouse? Okay, draw that rectangle first. The area is 24, at least it's a smaller number, and we want the width to be 2/3 of the length. So 2/3 times the length is going to be the width, and then the length is unknown. But we know area equals length times width. I write all these not just for your benefit too, but for mine. I need to see it. My brain needs to see this stuff. My brain wants to see it all laid out for me. Okay. How can I build 24 just so I can get an idea? I can do 6 times 4 to get 24. So why don't I call the long side would be 6, and then obviously it's not going to be 4 perfectly, but I'm just getting my pinpoint. So I'm going to use that. I'm going to say, what if the length is 6? Is 4 2/3 of that? So I'm going to try that. So if the length is 6, then I'm going to also multiply 2/3 times 6, because that is how I will get the width, 2/3 times the length, which I said is 6. Okay, and we want it to be 24. Let's hope our first guess. Can you imagine if our first guess? That would be awesome. Anyways, okay. I see cross reduction here available right here. 3 goes into both of those numbers, so let's do that. 3 goes into 3 once. 3 goes into 6 twice. 2 times 2 is 4. Oh my gosh. Oh my gosh. 1 times 1 is 1. And 6 times 4 is 24. Oh my gosh. I am so excited that first guess got us there. Nailed it. Winner, winner, chicken dinner. All right. Our guess was 6 feet. And choose the two numbers that have a product, 6 feet and 4 feet. We did 2/3 times 6, and we got 4, and my guess is correct the first time. Oh, that's so nice. Okay, we won't get that lucky every time. Anyways, that's all this is. Use what you know about factors to help you hone in on the kind of a close proximity, and then you make small adjustments from there. Tough one, I know, but don't worry, you can power through. You're really, really smart.